Good afternoon. कैसे हैं आप? How you doing? We are going to look at solutions and kinetics are. Oh, there's two of me on this screen. Hey, we're wearing the same colors. So yeah, solution and kinetics exemplar और एक interesting question JEE Advanced के point of view से हम लोग जरूर करेंगे. Why are we doing exemplar? Because JEE main exactly सवाल उससे directly पूछ रहा है. So let's practice because आप लोग खुद नहीं करते उसमें आपके लिए practice कर रहा हूँ. By the way, if you're preparing for JEE, I think it'll really help you if you watch these sessions and also जो NEET channel के sessions है उसको भी देखिए because there I'm solving the NCERT subjective questions, similar topics. So at 6:30 I'm going to be doing GOC there. We're going to start off organic. It's going to be good fun. But for now, solutions kinetics. Awaz saaf aa rahi hai? Able to hear me and see me? Rick. What's up? Narayan Chandra Shlok. Good evening. Raj Studio. Everybody here. Very excited. Me too. So how many of you saw this weird video that I posted? Oh wow, this frame looks scary now, huh? RO, exactly. Yeah. So I'm gonna just play this, and this is what we're gonna do at the end of this. We're gonna discuss how this works at the end of the session. Okay. Let me know if you can hear it. Look at that. It's about 450. That's the number that it settles down on. And after the water gets purified, the number comes down to about 30. How is that? How does this work, really? What's the science behind this? Come check it out on my session on the 7th of March on solutions and kinetics on the Aakash Byju's JEE channel. This is that session. Yeah, that's what we're talking about. So you're able to hear that, see that. Why did I play that again for you? That we're going to do that at the end of this session. Okay, around 5:15 is when we'll start that. आवाज आ रही थी? Please tell me you heard all of that. It'll be very funny if it was just like some mute video that was playing. Hey, what's up, Jay? Jay, how do I say that? Anyway, let's start. Okay, so this is where we are at. This is the general plan till the 16th. 18th onwards, we're going to be doing JEET. JEE ki tayari, 18 to 22nd. You know the drill, right? 5 days, 5 sessions per subject, etc. And 1.5 hours each. The biggest deal is you're going to have access to the app till the 31st of May. This is the pricing. You can get the, क्या बोलते हैं उसको, description में link है, उसको click कर सकते हो. You can use both of these codes, get 10 and this one, and you'll get a couple of $100 off on this. All right, let's get started. पहला सवाल. Yeah, all right. Okay, great. RO की working हमेशा पता है. Question में क्या होगा? That's what you're curious about. All right. पानी कितना waste होता है? That's what you're going to find out. How much water is एक छोटी सी पाइप होती है ना, इससे पानी वेस्ट होता है, उसमें कितना पानी निकलता है प्यूरिफाई करने में. That's what we're going to do. Which of the following units is useful in relating concentration of solution with its vapor pressure? No time being wasted whatsoever. 2 minutes in, we have started. 4 minutes in, okay. Which of the following units is useful in relating concentration of solution with its vapor pressure? Vapor pressure, matlab, what is the deal? Why are we talking about vapor pressure? Because that is what decides everything. This is the cause. Okay, effect बहुत चीजें हैं, but cause है vapor pressure. So if I plot pressure this way and I plot temperature this way, then this is a phase diagram, right? यहाँ पे, और पानी का, by the way, this is water, so it looks like this. If it was CO2 or any other thing, it would look differently. ठीक है, उल्टा बना दिया. ठीक है, पानी का negative coefficient होता है, right? Okay, great. Now there is a relative lowering of vapor pressure, जिसकी वजह से, say if this is 1 atmosphere, then देखिए क्या होता है. Delta T B इस तरफ बढ़ जाता है एंड इस तरफ डेल्टा टी एफ कम हो जाता है. ऑल एंड दीज आर इफेक्ट. कॉज क्या है? कॉज है वेपर प्रेशर लोअरिंग, डेल्टा पी. ओके, दिस इज द कॉज. नाउ मैंने ये सब कहानी आपको क्यों बताई? बिकॉज यू हैव डेल्टा पी बाय पी इज इक्वल टू व्हाट? क्या होता है? पीओ ए एक्स ए. ओके हर्ष, व्हाट्स हैपनिंग? ओके, so what's the answer to this one? Molality, mass percentage, parts per million, or mole fraction? What do you think on this one? P naught A XA. XA क्या है? Mole fraction. Okay. Shlok says mole fraction. Any other takers on this one? Going once, going twice. Sold to Shlok with mole fraction. बिल्कुल सही बोला. P naught A into XA is PA, right? And this is for an ideal solution. We do PA here, PB here, and this is how it works, right? For an ideal solution, this is what it look like. Where, which इन दोनों में से which is the more volatile one? थोड़ा theory भी revise कर लेते हैं. More volatile कौन सा इधर? A or B? In this diagram that I have drawn, very rough diagram. This is P versus X, etc. इन दोनों में से कौन सा ज्यादा volatile है? A या B? Mole fraction 1. Okay, cool. Shlok, yeah. All Harsh, you guys got right. Rec as well. Which one's more volatile, A या B? I've randomly drawn something, right? It means कि जो P naught A is greater than P naught B. हाँ, इससे volatility का पता चल सकता है क्या? Rex says A, विराट says B. Okay. इसको यूनिट से भी देख सकते हैं. हाँ हर्ष, ओके, गुड आइडिया यूनिट. विराट हैज चेंज आंसर टू ए. या एब्सोल्युटली, ए इज मोर वोलेटाइल. अगर वेपर प्रेशर ज्यादा है तो इट्स मोर वोलेटाइल. व्हाई? बिकॉज रिमेंबर, ये जो मैंने यहाँ पे ग्राफ ड्रॉ किया था, दिस ग्राफ राइट हियर, व्हाट डज दिस से? व्हाट इज बॉइलिंग? बॉइलिंग इज व्हेन वेपर प्रेशर इज इक्वल टू एटमॉस्फेरिक प्रेशर. ओके, सो अगर वेपर प्रेशर ज्यादा मतलब आसानी से वो वोलेटाइल है, आसानी से उसके प्रेशर पार्टिकल्स गो इनटू द गैसियस स्टेट. फर्स्ट क्वेश्चन, बट वी रिवाइज क्वाइट अ फ्यू आइडियाज इसमें. ठीक है, अब तो चीजें चिल होगी. लो कॉन्सेंट्रेशन ऑफ ऑक्सीजन इन द ब्लड एंड टिश्यूज ऑफ पीपल लिविंग एट हाई एल्टीट्यूड इज ड्यू टू व्हाट? Is it low temperature, low atmospheric pressure, high atmospheric pressure, or both low temperature and high atmospheric pressure? High atmospheric, high तो नहीं होगा ना, low atmospheric pressure होगा. जब आप पहाड़ों में रहते हैं, पहाड़ों में कॉन्सेंट्रेशन ऑक्सीजन की कम होती है ब्लड में और टिश्यूज में. क्यों? Why is that? What do you think? Rek is saying 2. Okay, Shlok is saying 2. Leads to anoxia. What is anoxia? Oh, blood, the poisoning and stuff. Is that what you're talking about? विराट, मैं समझा नहीं. Can you attend? Everybody can attend. Free country, जिसको attend करना है करे. What do you think about this one? Okay, so which of these do you think is the issue? Is it the temperature or pressure? ये तो गलत है, ये भी गलत है, because it's not high. What is the issue here? किसी को याद है? This is Henry's law, and this again directly from NCERT, right? As temperature increases, KH value increases. So temperature falls, KH value will fall. Does that have anything to do with this? What do you think? So no, not that either. अगर KH value कम होगी तब तो अच्छी बात है ना. KH value कम मतलब कि ज्यादा गैस डिसॉल्व हो जाएगी. That doesn't work either. That's why it must be the only answer that makes sense is low atmospheric pressure, because low atmospheric pressure पे one for bit side, yeah, absolutely, for bit side works as well. Shlok and Rek have both given the answer to be 2. Harsh is also saying 2. These are easy questions. If you have any doubts, please feel free to ask me. Okay, I gave you that KH thing just so that you know, okay, bhai, what does Henry's law have to do with any of this in any way, right? Oxygen क्या है? Gas. Blood क्या है? Liquid. So blood is being dissolved in liquid, right? Henry's law, pressure increase. नहीं, no. P is KH times X. Okay. Although K जो है कम होता है, P भी कम हो जाता है. ठीक है. Both of these are falling. So it's not low temperature that's a problem. It's the low atmospheric pressure that's a problem. ठीक है. Next वाला. Consider the formation, breaking and strength of hydrogen bond. Predict which of the following mixtures will show a positive deviation from Raoult's law. मैं जब तक आप मुझे इसका आंसर बताएं, I'm going to draw a beautiful diagram for you. Very nice and awesome diagram. Now this is a non-ideal mixture. ठीक है, वही सेम जो मैंने बताया था पहले, PA, PB or rather P naught A, P naught B, right? I can draw the same thing versus temperature. This is pressure, this is temperature. Interestingly, temperature का exactly इससे उल्टा होगा. ठीक है, which means कि low temperature, high pressure. So their natures are going to be exactly opposite. It makes sense, right? अगर कोई ज्यादा volatile है मतलब उसका boiling point low होगा. अगर वो कम volatile है तो boiling point ज्यादा होगा. Exactly उल्टा हो जाता है. And if you go into a little bit more detail, you say कि oh, there's a minimum boiling point mixture. That would be an azeotrope. ठीक है, exactly इस mixture पे constant boiling point, constant composition का boiling point, this would be an azeotrope. ठीक है, पूरा हम लोग थ्योरी साथ साथ कर रहे हैं रिवाइज बिकॉज इट्स पॉसिबल है. कभी कभी ये थ्योरी रिवाइज करना पॉसिबल नहीं होता है, बट इसमें यहाँ पे पॉसिबल है. विराट सेज बी, एसिड प्लस वाटर इज नेगेटिव डेविएशन. ओके, रेक्स सेज डी. ओके, श्लोक इज सेइंग कि एनोक्सिया इज द कंडीशन वेयर माइंड स्टार्ट्स बिहेविंग ओके लो कॉन्सेंट्रेट, या लाइक यू स्टार्ट hallucinating, there isn't enough oxygen. Okay, all right, nice श्लोक. ओके, सो इसका आंसर क्या होगा? लो पॉजिटिव डेविएशन मतलब कि लो temperature, which means कि AA and BB are greater, not very much greater, but greater than AB. तो कुछ AA के खुद के इंट्रैक्शन है, BB के खुद के इंट्रैक्शन है जिनको मैं डिस्टर्ब कर रहा हूं, जिसकी वजह से AB इंट्रैक्शन आर वीकर. ठीक है, So this has hydrogen bonding. So does this. So does this. So does this. अब क्या करें? सब में hydrogen bonding. But in this, the bonding is really, really good. Hydrogen bonding is really good. Phenol and aniline. Oh, this looks like this could be a contender for a high boiling point mixture. Yeah, इन दोनों के बीच में. So this is high BP. This also is high BP. Chloroform and acetone. Chloroform and acetone. सोचना पड़ेगा. इसमें भी शायद CHCl3 and this. इसका क्या है? I'm a little confused between 1 and 2. What do you think? 68% azeotrope. श्लोक को बिल्कुल पक्का याद है. Rec D तो नहीं होगा ना? Rec D would be a high boiling point mixture, right? Because of this hydrogen bonding between this aniline K electrons and hydrogen, etc., etc. Right? I think so. Or what do you think, Rec? ये वाले सवाल ऐसे ही होते हैं. You either know it or you don't. If you have read it somewhere and you remember it, you know it. Otherwise, on the spot, सोचने में कभी-कभी you can mess things up if you think on the spot. B, you think boards में था. Okay, all right. Anybody else wants to take a stab at this? These are direct questions, but it's okay अगर थोड़ा सा challenging लगता है, because theory है, logic तो जरूर है, but logic के साथ क्या है कि कभी-कभी थोड़ा बहुत आगे पीछे हो जाता है. So let's see. I'll wait for a couple of more people to give me some sort of an answer. Then we'll go ahead and discuss it very quickly. I've given you a hint as to क्या होगा anyway. I've given you a hint. So the deal is कि methanol में हाइड्रोजन बॉन्डिंग एज इट इज है, राइट? मेथनॉल इज जस्ट लाइक एथेनॉल. एथेनॉल में हाइड्रोजन बॉन्डिंग बहुत स्ट्रांग होती है. उसमें एसीटोन डालने की वजह से दैट हाइड्रोजन बॉन्डिंग गेट्स डिसरप्टेड. ओके, व्हेयरएज क्लोरोफॉर्म में आई एम नॉट टू थिंक अबाउट क्लोरोफॉर्म. आई हैव टू थिंक अबाउट क्लोरोफॉर्म वाला ऑप्शन. लेट मी जस्ट सी. आई एम क्वाइट श्योर ए इज करेक्ट. आई एम जस्ट ट्राइंग टू सी इफ समहाउ बी आल्सो कुड बी कहीं पे मिला. बी का भी कुछ लॉजिक. होल्ड ऑन सर. ओपन एनसीईआरटी इफ पॉसिबल. विराट, इतने भी लेजी मत बनो. एनसीईआरटी खुद ही खोल लो. पीवाईक्यू है, पीवाईक्यू नहीं है ये एग्जाम्पलर का है. ये एनसीईआरटी से तो है. विराट, आई थिंक यू हैव मिस्ड द पॉइंट ऑफ दिस. दिस इज फ्रॉम एनसीईआरटी. दिस इज एनसीईआरटी एग्जाम्पलर. सेशन का नाम है एग्जाम्पलर. ये सवाल है एग्जाम्पलर से. एंड द रीजन व्हाई इट्स अ पीवाईक्यू इज बिकॉज जेई में डायरेक्टली वहीं से सवाल आ रहे हैं. या ऑल राइट. This I feel should be A. I'm not so sure about B. I'm looking for B, chloroform and acetone. I'll check for B as well. चलो, कोई बोल रहा है NCERT खोल रहे हैं तो चलो, let's open NCERT. This is a good time pass, but all right, let's go ahead and do it. Solutions, grade 12. Oh wow. अरे ये तो मुझे कुछ अजीब. अच्छा, अरे यार, this is giving me solutions of something. PDF solutions. Chloroform and dichloromethane, chloroform and acetones. देख लो भैया, देख लो. हाइड्रोजन बॉन्डिंग दोनों के बीच में होती है. एनसीईआरटी खोलने को जिसने बोला था ना, खुद थोड़ा पढ़ भी लेते तो लाइफ थोड़ी अच्छी होती. देखो भाई साहब, here you go, highlighted text. Similarly, a mixture of chloroform and acetone forms a solution with negative deviation from Raoult's law. और यहाँ देखो, ब्यूटीफुल बना हुआ है यहाँ पे. इसको कैसे आप लोग करें? What do you call this? Yeah, these were just copies of the same thing. See here? Yeah, happy? Cool? भाई साहब, खुद तो पढ़ेंगे नहीं और फिर बोलेंगे एनसीईआरटी खोलो. सही है, ठीक है. या just like ethanol and water. Yeah. All right, cool. Now this one's interesting. In comparison to 0.01 molar solution of glucose, the depression in freezing point of a 0.01 molar MgCl2 solution क्या होगा? इसको you can do, right? Assume कि fully dissociate होता है, where I is equal to क्या? MgCl2. आप लोग करो solve until I'll just write this down. What is the concept of I anyway? Let me do that theory. I is observed particles. Remember it like this. Life will be easy. Divided by theoretical number of particles. Number of particles. Okay? So, in this case, if there is dissociation, then I will be greater than 1. Agar association hai, so I will be less than 1. That's a general idea. Here, clearly, Cl2 minus. Khair, I here is going to be 3. Okay. So answer should be about 3 times, है ना? इसमें क्या सोचना है? Yeah, should be easy. Should be M instead of M. Shlok says छोटा m instead of capital M. Let me. It doesn't matter, no? Shlok. There are both ways of representing concentration. अगर मैं तुमको मोलैरिटी दूं, तो आप उसको मोलैरिटी में कन्वर्ट कर सकते हो. You just need density. I mean, it's the choice of the person who has measured it. ना उसको molarity measure करना ज्यादा आसान लगा, molality उसको ज्यादा मुश्किल लगा, right? Because if he has a volumetric flask, it is easier to do that as compared. Usually, weighing थोड़ा मुश्किल होता है, because weighing में you always need a physical thing, whereas volume measure करना आसान होता है because the graduated cylinder, right? In the lab मैं तुमको practical चीज बता रहा हूँ. वे करना चीजों को मुश्किल होता है, which is why I would report molarity and then convert to molality. उसमें क्या है? Molarity is what? It is mole per liter, right? Mole of what? Mole of solute by liter of solution. And what is this? This is same thing, numerator same है, which is mole solute divided by 1 kg of solvent. Now, how do I convert liter of solution to 1 kg of solvent? So, I say कि अच्छा, this is going to have 1 kg solvent plus some, whatever this was, mole solute times density of solute, not density, sorry, mole solute times क्या molar mass of solute. ठीक है? This whole thing divided by density of solution will give me volume of solution. First principle से करो कभी ये इस टाइप के डाउट you'll never have if you do things from first principle. Sorry, सर के पीछे थोड़ा चला गया. I'll give these notes you. देख लेना. इसका आंसर हो 3 times. That was easy. Yeah. What's up, Vedant? Good to see you. I is number of particles after dissociation divided by before this. Yeah, absolutely. Glucose I is equal to 1. Yes, rec. I is equal to 3. All right. Perfect. All right. Good evening, fan sahab. I'm good. How are you? An unripe mango is placed in a concentrated salt solution. I don't know why you would do that. Unripe. अच्छा ये हम लोग तो अचार बना रहे हैं. Unripe mango मतलब अचार. Concentrated salt solution. इसे ऐसे तो बनता है अचार. किसी ने बनाया अचार? To prepare pickle. अरे अगले लाइन में prepare pickle. ठीक है यार. Shrivels because it gains water due to osmosis, loses water due to reverse osmosis, gains water due to reverse osmosis, loses water due to osmosis. I like this question because it is testing the idea of whether you know what is happening and do you understand what osmosis is. तो जब तक आप मुझे जवाब बताते हो मैं जल्दी से आपको osmosis का आइडिया बता देता हूं. ठीक है? This is the easiest way to do it. So there is a membrane over here. Now what happens is that this membrane, it lets solvent pass. So say here there is pure solvent idhar, and idhar hai not so pure. This is what do you call it? This is it has non-volatile solute plus solvent. So in a sense यहाँ पे solvent की quantity concentration कम है. So solvent अगर पानी लो इस direction में जाएगा, and hence you will get थोड़ा सा ये ऊपर चला जाएगा, थोड़ा सा ये नीचे. तो this is basically, if you measure this converted density, you will get this osmotic pressure. What that also means is कि अगर आप इस तरफ से pressure apply करो to stop osmosis, that is osmotic pressure. I like how हम लोग जो है थोड़ा थोड़ा चिल करके पूरा थ्योरी भी कर ही दे रहे हैं. That's all this chapter. This chapter is simple, इसलिए हम लोग थ्योरी भी कर रहे हैं. सर ने बनाया है. नहीं, ये मैंने नहीं बनाया है, एग्जाम्पलर का है. All right. Exemplar questions 4. Okay. Cool. All right. Good. अच्छा आपने बनाया है. That's good. आचार बनाया है. बढ़िया. Okay. Answer is D. Harsh, Rek, King Fan, Shlok. Everyone saying D, which is great. It loses water due to osmosis. मतलब concentrated salt solution is like this RHS. है ना? Ripe mango, unripe mango placed is like theoretically it is. Well, it is like this. It is like LHS. यही हो रहा है. पानी यहाँ से वहां जा रहा है. इसमें salt नहीं है, इसमें है. That's all. ठीक है? Perfect. Good job. You're all figuring this out very easily. Value of इसका मैं आंसर आपको ऑलरेडी दे चुका हूँ. Value of Henry's constant KH increases with increase in temperature, decreases with increase in temperature, remains constant. First increases, then decreases. फोर्थ वाला ऑप्शन क्रॉस कर दें. ये तो डमी ऑप्शन लग रहा है. टेम्परेचर के साथ थिंग्स डोंट, दैट डजंट हैपन unless there is some denaturation suddenly of a protein or something जिसकी वजह से this does not happen. All right. अच्छा, आपने अचार बनाया है? Okay, okay, श्लोक. All right, good, good, good. Oh, that's great. Mango pickle is the best. King Fan is saying B. Shlok is saying 1. Okay, okay. So we have one person for 2, one person for 1. बाकी लोगों को क्या लगता है? See, Henry's law constant, and this is just theory. There's no way around this because I haven't done solutions ka theory sessions with you. Maybe if I would have, we would have gone into a little bit of detail about how this whole idea works. But the solution ka idea thoda sa complicated hai. So we'll just have to mug it and take it with a, this thing ki bhai, it increases with increase in temperature. That's all. Okay. And this is why solubility of gases decreases with an increase in temperature. क्यों? क्योंकि देखो P is KH times X. अगर KH बढ़ गया तो X must fall. अगर P सेम रहा तो, है ना? तो बाहर का प्रेशर तो सेम ही है, राइट? मैंने गर्म किया, KH बढ़ गया, X कम हो गया. तो the answer is increases with increase in temperature, and the easy way to remember that is कि अच्छा, जब तुम गर्म करते हो किसी चीज को तो उसकी मतलब पानी को गर्म करते हो तो उसका जो है सॉल्युबिलिटी, उसमें सॉल्युबिलिटी ऑफ समथिंग एल्स कम हो जाती है. वो सब आपने शायद 10th स्टैंडर्ड में भी पढ़ा था, 10th या 9th स्टैंडर्ड में पढ़ा होगा कि why does a cold drink go flat when you reduce the temperature, room temperature में? Why does it say कि serve chilled, taste best when chilled? Because उसमें जो है गैस अच्छी तरह डिसॉल्व होती है. जैसे आप बाहर रखोगे, खोलोगे, या एग्जैक्टली, यस यस, नो इट इज C. आई किंग फैन, नो इट्स नॉट C. अच्छा रेक, आपको C क्यों लगता है? Okay, what is the logic behind C? अरे सब लोग रिट्रैक्ट कर रहे हैं मैसेजेस, ठीक है, ऑलराइट. NRT/V is directly proportional to KH. Interesting. You good, right? You good as to why the answer should be 1? Everybody on the chat right now? My focus is you guys. I know a lot of people are going to watch this later on. This one's interesting. Shlok, he's going to take this one personally. We have 3 aqueous solutions of NaCl labeled as A, B, and C with concentrations, 3 of them given right here. The value of Van 't Hoff factor for these solutions will be in the order what? This, okay, good, Rick. Now this one is a little controversial, and the reason behind this, we will have to open up our good friend the NCERT. वो कहाँ गया, वो विराट कोहली जो बोल रहा था NCERT खोलो? अभी NCERT खोल ली हम लोगों ने. The answer key given, this came in as a PYQ, this जनवरी के पेपर में ही आया था, ठीक है. Hold on. अच्छा, यहाँ मोलैरिटी दी गई है. Yeah, this is a little confusing, right? And ये Vant का spelling थोड़ा गलत है, which I'm trying to fix. Vant में spelling is like this. There is a space between Van and T. कहाँ गया ये? This is the actual this thing. So now NCERT says something that could confuse a few students. Let me show you what I'm talking about. This table right here, right? You see this table? It says कि values of Van 't Hoff factor I at various concentration for NaCl, etc., etc., etc. NaCl का concentration when is 0.1 molar, ये होता है value of I. But अगर complete dissociation हो गया solute का, तब 2 ही रहेगा, ठीक है. Incomplete dissociation since लिखा नहीं है, yeah, it is not written, so we will assume कि it is complete dissociation, ठीक है. And this is one of those cases जहाँ पे NCERT पढ़ने से we like, अरे यार मैंने NCERT में पढ़ा था but मुझे गलत याद हो गया. It could happen, right? Could be detrimental अगर हम लोग जबरदस्ती NCERT ज्यादा डिटेल में पढ़ रहे हैं but we don't remember some parts of it. It is C, right? It is C. Should be 1. The table at NCERT. Shlok has PTSD from this. The answer is 3. Yeah, they are all the same. I की value सब में same ही होगी. Yeah, because these are whatchamacallit. They fully dissociate. That's what we assume, unless somebody tells us accordingly, differently. उन्होंने properly frame नहीं किया, हो सकता है श्लोक. Cool. All right. Let's go to the next question. The reason I brought this question again is because this came in the JEE exam. Unlikely कि फिर से आएगा, अभी already आया था, but just so that we could discuss it. Now on to kinetics. At almost near the halfway mark, we're on to kinetics. Mark the correct option. Activation energy of forward reaction is E1 plus E2 and product is less stable than reactant. Okay. Activation of forward reaction is blah blah blah. Product is more stable than reactant. Okay. Stability more less कैसे पता करोगे? Activation energy of both forward and backward. अच्छा. So looks like this is talking about 2 points. One is EA and the other thing is stability of product. Product versus reactant. ये दोनों चीजें की हम लोग यहाँ बात कर रहे हैं. How do we address or assess both of these things? Let me highlight that यहाँ फिर से. Activation energy. This is forward. This is backward. आप लोग बताइए what you think until let me walk you through this. People are not watching this live, right? So मुझे लगता है कि अगर मैं reactant side से जा रहा हूँ और मुझे forward जाना है, then I have to overcome this hill. Now this hill is E1 plus E2. So I would say that EA forward would be equal to this. Similarly, EA backward will be मैं पीछे जाना तो मैं I'm already at products. So the hill is smaller. The hill is just E1. Okay. अरे ये तो बिल्कुल मेरे सर के पीछे चला गया. Okay. EA backward is going to be simply E1. Okay, that is clear. Now, what is this idea of, we will look at the options, that's okay. Now, what is the idea of stability? Lower energy means more stable. Lower energy, more stable. That's the idea we can go with. So in this case, it is very clear that reactants are more stable because they are at a lower energy. Okay, now let's look at the options. I'll also look at the comments. पहले क्या बोल रहे हैं आप लोग? They should have said, okay, complete dissociation. हाँ, Shlok, I agree, because usually you would assume in different concentration we have different levels of dissociation. Yeah, it's okay, Shlok, let it go. I know, let it go. Energy high, so less stable. Okay, Rex says 1, so 1 is correct. All right, energy with a lot of spaces. Rex Shlok, absolutely right. Activation energy of forward reaction is this. This is something we have deduced. Activation energy of forward is, so this one is correct. E1 plus E2 मतलब ये वाला सही है, activation both forward नहीं. This is not right because backward उल्टा है. Activation backward is E1. This is correct. Product is more stable than reactant. No, this part is wrong. We have figured out that product is less stable than the reactant because product has a higher energy than the reactant. So the answer of this is going to be the first one right here. Next question, और ये भी आया था JEE main में इसी बार आया था, right? This is the reason. This is one of those 1 and 4. मेरी तो शिफ्ट का भी नहीं है था वो क्वेश्चन. श्लोक, ओके, ऑलराइट. ये भी आया था. दिस केम इन द लास्ट पेपर. आई थिंक द टफ सेट. कम ऑन गाइस, सब कुछ. इफ यू आर गेटिंग क्वेश्चंस डायरेक्टली फ्रॉम एग्जाम्पलर, इट इज नॉट अ टफ सेट. ठीक है, लेट मी बी वेरी स्ट्रेट विथ यू, एटलीस्ट अबाउट केमिस्ट्री. हो सकता है मैथ्स टफ होगा, आई डोंट नो, आई डिड नॉट सॉल्व द मैथ पेपर, बट ब्रो, अगर तुम्हारा सवाल एनसीईआरटी से डायरेक्टली आ रहा है, प्लीज डोंट क्रिब अबाउट इट बीइंग अ टफ सेट. ठीक है, एनसीईआरटी पढ़ लो. This is literally the book that is prescribed for the syllabus. ठीक है. Here, this, hold on. So your first order gas phase reaction decomposition reaction given initial pressure system before decomposition was P, small t. After a lapse of time T, total pressure system increased by X units and becomes PT. The rate constant for K is given to be what? I have a feeling इसमें कुछ थोड़ा सा टाइपो है. टफ नहीं था, रिएक्शन नहीं दी थी. ये मेरे में आया था, लीव करना पड़ा, रिएक्शन नहीं दी थी, ओनली ऑप्शंस थे. फर्स्ट ऑर्डर दिया था ना, तो रिएक्शन दी थी यार, राइट? अच्छा, मे बी, आई डोंट नो, इफ यू आर सेइंग नहीं दी थी तो नहीं दी थी, बिकॉज आई हैड द पेपर फ्रॉम आकाश, राइट, एंड वी सॉल्व दिस एंड वी लाइक होल्ड ऑन, ये तो हमने इसका पहले ही किया था, वी जस्ट सॉल्व समथिंग सिमिलर टू दिस. सो अ क्विक वे ऑफ सॉल्विंग दिस, एंड अ वेरी क्विक वे ऑफ सॉल्विंग दिस इज जस्ट टू गेट दिस सॉर्ट ऑफ क्या बोलते हैं इसको, relationship between these. If you get that relationship, you can figure out कि अच्छा, which one of this is it going to be, and you don't have to go too much in detail. Okay, so initial pressure was PT or final pressure is PT. B में T की जगह I आएगा, says Harsh. Okay, नहीं, I'm not saying, you can call it tough, that's absolutely fine, but crying out it saying कि oh, you know what, NCERT NTA ने कुछ गड़बड़ की, come on guys. I understand if you say that एग्जाम के दौरान करने में मुश्किल हुई, ऑल्दो द क्वेश्चन वाज डायरेक्ट, पर एग्जाम के दौरान प्रेशर के कारण मुश्किल था, दैट आई अंडरस्टैंड, बट सेइंग दैट दिस वाज अ टफ सेट एंड इंसाफ ना इंसाफी हुई, कम ऑन, दैट्स नॉट फेयर, दैट्स नॉट फेयर एट ऑल. Anyway, let's go ahead and do this. PI होना चाहिए, right? Not PT. Hold on. I feel that there's a bit of a typo on this. I'm getting the exemplar वाला thing open. The PDF जो मुझे अभी मिल नहीं रहा है. Exemplar PDF of Kinetics. कि दोनों PT तो नहीं होने चाहिए, right? Question number 5. हाँ, PI होना चाहिए, यही तो बोल रहे थे. पहला वाला होगा PI, पहला वाला PT क्यों होगा? Typos. We will fix the typo right here. Don't worry, आपके एग्जाम में टाइपो नहीं होगा. This is an us problem. Underscore IT. अरे, okay, fixed. Okay, now let me fix the other one. तब तक आप मुझे बताइए आपको क्या लगता है आंसर. This is PI, okay, not PT. There you go. This one is PT. Okay, fixed. What do you think? Can you take some time and derive this? It's okay. No hurry. Take your time and derive this, please. How do we do this one? Where is my chat? Here is my chat. Shlok says 1. Okay. What happened here? Jeez, this is weirding out, huh? Okay, I don't know why it's gone all bonkers, but PPTs are behaving weirds. Oh my god, dude. Okay, great. That should be better. सब जगह italics हटा दिए मैंने. Technology problems. Okay, so how do we go ahead and solve it, right? Initially, pi 0 and 0, then pi minus x, x and x. So pi plus x is equal to pt. Okay, so x is equal to pt minus pi. You good so far? Are we good so far? Yeah. Now that we've got this, what is pi minus x? Pi minus x is going to be equal to pi minus pt plus pi. Oh, so you get 2 pi minus pt. Arey yaar, this amazing. Ruko. Apologies for the typing, guys. That should be it. Hey, option B और C सेम लग रहा है क्या? नहीं, option B और C सेम नहीं है. Okay. Now I have finally fixed the typos. Okay, cool. Is we good? है ना? श्लोक जल्दी नहीं करना, आराम से करने को बोला. बी में ची के आई आएगा. हाँ, हर्ष बिल्कुल सही बोला आपने. थैंक यू हर्ष. Wonderful. Shlok, Harsh, right? You figured this out. Yeah, exactly. So this is all you've got to do. This question may look a little daunting because you're using ideas from equilibrium and also kinetics साथ में, right? But do it from first principles. कोई जल्दी नहीं है. ठीक है? This is A, this is B, this is C. I know exam में थोड़ी जल्दी होती है, but you have 1 hour for 25 questions. कुछ inorganic के सवाल तुरंत हो जाएंगे, कुछ में time लगेगा, right? So we good? Shall we move on to the next one? Any doubts in this? I took time for this because I did not want you to think कि इसमें कोई बड़ी चीजें करने के लिए. I wanted to prove to you कि it's very doable very quickly. कोई भी fancy चीज इसमें नहीं है. कोई crazy where did this guy go? Oh, is this a question? This is a question. अरे वाह man, after fixing all of this typo, that's still no. All right, option B. There you go. We're fixing it. I have a feeling I may have messed up something of the previous question. Okay, so sorry. नहीं, ठीक है, chill है. It's good. इसके ऊपर क्या PYQ बने हैं? No doubts, clear. Okay, easy था, right? It's okay. So at the last time when we spoke, I mentioned about shooting percentages, right? That practice में you may have like 3-pointers. People, there was a very crazy shooter who had like a 90% or 70% conversion rate, but in actual game उसका percentage कम था. And these are open threes, okay, free, no one contesting them. Exam pressure is a real thing. So don't beat yourself up about it. अगर थोड़ा सा आगे पीछे होता है, भाई आसान लग रहा है, एग्जाम में हो सकता है मुश्किल हो, don't worry about it. Which of the following expressions is correct for the rate of reaction given below? Sometimes students get confused in this, so I'll want to talk about this for a minute. You may see the question and know the answer right away. ऐसा भी हो सकता है कभी-कभी कि यार Is it this? Is it that? Sometimes we get confused. So let's address that confusion. Let's address that. So what do we do here? Okay, we've got to relate BR and H. So is it 5 by 6? Is it 6 by 5? That is what I want to address. Okay, let's make it into one. No, it'll be easy. BR minus plus 6 by 5 H plus. This means for every mole of Br minus, 6 by 5 moles of H plus get consumed. है ना? Which means this is faster. Are you following? Are you following this? है ना? This is faster. Okay. Which means this is slower. Slower by how much? 5 by 6 times of H plus. समझ में आ रहा है? That's how you get this. Just an idea of ratio and proportions. फिर से repeat करता हूं. These are the actual moles. You make anyone. दूसरी तरफ भी कर सकते हो. Okay. Whatever you're comfortable with, make one of the units into one. In this case, I want to know bromide in with relation to H plus. So bromide 5 Br will react with 6 H plus. So 1 Br minus will react with 6 by 5 H plus. Matlab H plus gets consumed faster than Br minus, which means Br minus gets consumed slower than H plus. Slower option में बस एक ही है. 5 by 6 is the only one that is slower. Mark this. This is the answer. ठीक है. रेट लॉ तो ठीक है, बट कभी कभी स्टूडेंट्स 5 by 6 6 by 5 इसमें अपना दिमाग खराब करते हैं एंड गलत भी कर देते हैं. दिस इज द वे टू एनालाइज दिस इन योर माइंड. ओके, व्हाट इज द मीनिंग ऑफ फास्टर और स्लोअर? ऐसे करते हैं एनालाइज. ठीक है, दिस शुड बी द आंसर. लेट्स मूव ऑन टू द नेक्स्ट वन. आई होप यू एंजॉयड दैट स्मॉल छोटा सा एक tidbit idea that was there. Okay, so you got some chemical reaction, blah 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 blah. You know this, right? Okay, here you go. A plus 2B giving you 2C. What is the rate law if these experiments were carried out? Very doable. Rajshri, thank you for your answer. Absolutely right. 3 is the right answer. हाँ हर्ष, उसी के ऊपर काफी PYQ बने थे. बिल्कुल सही बोला आपने. जैन अटेम्प्ट में आई थिंक फर्स्ट को जो आया था पेपर, 30th को जो आया था पेपर, और फिर 29th का भी पेपर में, दोनों में इसी के आसपास क्वेश्चंस आए थे. बिल्कुल सही बोला. Now in this, you just have to divide two of these. And if you haven't seen my neat video, check it out. We've done that in detail over there. We'll do it a little quickly here, right? If I divide 2 by 1, then I can remove this. So I get 2 power n is equal to 4. So you get n equal to 2. That's it. And then if I divide, what can we divide? Let's divide 3 by 1. When we divide 3 by 1, equation 3 by 1, equation 2 by 1. Then I get 2 power n, I always say m, right? If I take the order of this, ulta ho gaya. A power b power n, b a power m. Yeah, my variables are beautiful. 2 power m is going to be equal to 2, so m is equal to 1. So the order is ab square, I want to say. Is that the right order? What are you getting? Are you getting ab square? I'm getting AB square. It's okay if you're getting something different. You don't have to get the same thing as me. You guys are so fast. Shlok and Raj lay on the head very quickly. जितने समय में लिख रहा था, already answer बता चुके. Any doubts in this? This is very basic. Has come in NEET in the past. Has come in JEE in the past. इस JEE में नहीं आया तो basically हो सकता है किनेटिक्स से सवाल आए तो मे बी April attempt में शायद ऐसी चीजें आ जाए. Very doable, but you need to know how to do this. Like एक बार you have to have done it. Only then it's easy. Otherwise, you're like, ye kya aa gaya? All right. According to Maxwell-Boltzmann distribution of energy. Whoa. Maxwell-Boltzmann distribution of energy. What is this doing here? The fraction of molecules with most probable kinetic energy decreases at higher temperatures. Fraction of molecules with most probable kinetic energy increases at higher temperatures. Most probable kinetic energy increases at higher temperatures. Most probable kinetic energy decreases. अरे यार. अब क्या करें? क्या करें? Most probable kinetic energy. Most probable kinetic energy होती क्या चीज है? This is the sort of a Gaussian curve, right? When you have velocity versus probability. when this is normalized, the area of the whole thing is 1, right? So most probable is basically you differentiate the curve equate to 0, which means it's a maxima, right? This is most probable speed or velocity. This is say at T1. Now at T2 what happens? Say activation energy kahan hai? Let's say this is the activation energy. ठीक है? Because velocity से आप energy निकाल सकते हो ना? What is energy? Energy is half mv square. So yeah, in a way I can represent energy on this axis, okay, because velocity is on this axis. I have to square it down, but I can do it. Okay. Now, if I increase the temperature, remember, it's normalized, which means area is 1. If the area is 1, that means कि अगर मैं temperature को बढ़ाऊंगा तो ये ग्राफ और spread out हो जाएगा. और spread out कैसे होगा? ऐसा होगा. ठीक है, this is T2 and these are your extra, fraction that's increasing. And but that is different. यहाँ पे सिर्फ MPS की बात हो रही है. Okay, but MPS बढ़ रही है, right? So VMPS increases, but not probability, but say number of particles. Probability is from number of particles. Let's just say number of particles that have that speed. That decreases. So fraction of molecules, yeah, fraction to number क्यों लिख रहा हूँ? Fraction लिख दे रहा ना. Fraction of particles. Basically n by n naught. यही तो है ये axis. That decreases. That decreases at higher temperature. I think it should be 1. I think 1 should be correct. That weird graph जो हर जगह use होता है, slope. Yes, this is the weird graph. I've drawn it for you. Rek is saying 3. This could be more than 1 correct, Rek. Hi Rajesh, how are you doing? 1 and 3 say slope. I identified एक से ज़्यादा correct है. Fraction versus kinetic energy. Yes, Harsh, exactly. Hey, Rafael. All right. Wow. Yeah. HCL wala. Yes, Vijay, Rafael. You're from the 9-10 channel, huh? That one video I did on Saturday. So anyway, yes, you're right. 1 and I'll get back to you, Rafael. Just give me a minute. Huh? 1 and 3 are correct. Fraction of molecules with most probable kinetic energy kam ho gayi. That we are showing by this blue thing. Okay, blue. And most probable kinetic energy increases. That is also being shown by blue, in fact. ये देखो यहाँ पे अगर नहीं, let's choose a different color. चलो, that's shown by green. ठीक है? Fraction बढ़ गया. Fraction कम हो गया. Actual VMPS increase. ठीक है? So it should be 1 and 3. Good job. Hold on, I just have to kick a guy out of the chat. All right, I'm done. 1 and 3, yeah. Okay, Rafael is saying, confusing question, chemistry study, science board exam, whether this metal did not react with HCl, could that be copper? Yes, Vijay Rafael. You're from the 910 channel. That's lovely. Vijay Rafael, by the way, is talking about a question with, since you guys are also here, there was an interesting question. They said कि there are 3 metals, magnesium, Fe, and was it aluminium? I think it was these 3, right? When they react with dilute HNO3, reaction hota hai. But with copper, it will not happen. But the question in the question, they did not have these. They did not have copper in the questions. Which of these did not react? So I said maybe it should be does not react, and does not agar hota and not did not. Typical CBSE stuff, right? So then the answer would be copper, and maybe you guys get marks for it. You should get marks for it. The answer would be copper. If it's concentrated HNO3, it's an oxidizing agent, and check out my session on redox reactions. Oh, by the way, I didn't give you that. Oh my God, what a crime! I didn't give you that. Hold on. I always do that. docs.google.com, the chem sessions, if you want to see them. Here they are. Going to pin this. Yeah, all the general chem. Okay. Last question for kinetics, or not last? Second last question. And then we do the solute one. What happens to most probable kinetic energy? And oh my God, I've explained this in so much detail. I forgot you had this question. I've already explained this to you. Okay, looks like, yeah, Rafael, I feel so. Anyway, I've already shown this to you. I drew the graph. I forgot that I had another question on the graph for you. But here is the graph. What happens to most probable kinetic energy and the energy of activation increase in temperature? Here it is. That wonderful graph that Shlok everybody has liked so much. The fraction increases. Yeah, we've already done this. I'll skip this. If you have any doubts, we do this. Rate is A E bar minus E A by RT. All right. Yeah. Most probable kinetic energy. MPK is just saying you use MPS, okay, in this calculation, energy of activation with increase in temperature. Energy of activation is the same, right? This guy increases. All right. Hey, Rishabh, Hare Krishna. Let's go to the next question. This was okay, whatever. For a binary ideal solution, last one, and then we do the fun question. The variation in total vapor pressure versus composition of solution is given by which of these curves? I have drawn this graph also for you like 100 times in this session. इसी सेशन में शुरुआत में आपको ड्रॉ कर चुका हूं. जल्दी बताइए इसका. You're most welcome, Rafael. What do you think about this one? This is like a 10-second thing. If this comes in the advance, you should be like, yay, एक सवाल हो गया बहुत आसानी से. Yeah. Please try this out. What do you think? Okay, Rushabh says 4. Okay. Rek also says 4. Could this be more than one correct? Kishore, good to see your answer. Kishore, Rek and Rushabh are saying D. Harsh also saying A. So, here's my, what do you call it? Point, right? If A is correct, D also should be correct. 1 and 4 both must be correct, right? It is not going to be curved. Curved means deviation from Raoult's law. What is Raoult's law? P naught A times XA is equal to PA. When this is the equation of a straight line, y equal to mx, right? Which is either this or this. Both could be right. Both could be right, right? So it is both 1 and 4 that are going to be right. Multi-correct. Yes. Dono se hoga. Yes, Rajshri. 1 and 4 are the same. Exactly, Shlok. Yuvraj. Hi. All right. On to the fun question. Yeah. This may seem like a very chill thing, and that's what JEE Main is. JEE Main has become chill. So make sure that your nerves are in the right place. आप लोग tension मत लो. Exam में ना हड़बड़ी हो जाती है. That is what you have to work on. The questions, as you can see, are very doable. Okay. Anyway, now on to the JEE Advanced idea/question. Okay. I showed you a video. I sent a short where I showed you actual numbers, and those numbers were good enough for me to do an actual calculation. Okay, and I haven't made this up. Okay, TDS value दी है 450 milligram per ml की borewell के पानी की. RO use किया. I showed you that it's not made up, right? Drinking water में थोड़ा dissolved solids होना चाहिए. उसी से तो पानी का टेस्ट आता है. We spoke about that in the last couple of sessions पहले ना कि पानी का स्वाद बहुत टेस्टी होता है. That's because it has some dissolved solids in it, and let's say 30 is a good number. 50-60 भी चलता है. Let's say 30 is a good number because मेरा RO वही दे रहा था. ठीक है. Now this RO, it applies a pressure of about 8 atmosphere and it gives me 45 liters daily. इसमें capacity है 45 liters daily पानी देने की. So what it essentially is doing in that YouTube manometer kind of a thing, I am applying pi of say 8 atmosphere across the semi-permeable membrane, and I'm getting, nice clean water. So I already have some clean water. इसका जो quantity बढ़ती आ रही है, this is 45 liter. ठीक है. But now here is the interesting thing. Look at question number 1. It says how much water is thrown away. Why do I have to throw water away? This happened. If you've seen the RO unit में एक चीज होती है, एक पतला सा पाइप होता है. उस पतले से पाइप में से water is always thrown out. Okay. And if you are daring enough, I'll suggest something else at the end of this कि क्या कर सकते हो to prove this. Okay. And you can assume that all solids are MgCO3 and temperatures 27 degrees Celsius. So इसका mass होता है कुछ 84 gram per mole, right? Mg is what? 24 plus 12 plus 48, right? Is that correct? 60, yeah, 84 gram per ml, right? Gram per mole. All right, cool. And second question is, would this purifier work with seawater? We'll address the second one after we understand first वाला कैसे किया जाए. ठीक है. पहली बात ये है कि what is the concentration of solute? How do we get that? Can we start this question off? Yes, exactly, Harsh. Minerals 2, गंगोत्री के टॉप में मीठा पानी, थोड़ा सा नीचे जाओ, जानलेवा पानी. Okay, ऋषभ, गुब्बारे भरे होली के लिए. Conserve the mass. अरे श्लोक, mass conservation, I like it. Mass transfer. We are talking about mass transfer. जो अंदर आया वही बाहर जाएगा. Okay, lovely. I like that श्लोक. Conserve the mass of impurity. That's exactly what we're going to do, right? How are you going to do that? We're going to say that m into v is constant. Okay, that's what we're going to do. But what is this m into v for the first one? I'm saying that 45 minus 30, 450 tha, not 45. I'm getting it down to 30. Matlab, I am removing 420 microgram per ml of the solid. Now, I have taken I to be 1. Why did I do that? Why did I take I to be 1? Because MgCO3 की solubility is low. I'll show you the solubility of MgCO3. कोई पूछेगा उससे पहले आपको बता ही देता हूं. How did you take this? How is I? Yeah, ptable.com. अरे नहीं, इसमें नहीं होगा. ptable में तो नहीं, कार्बोनेट शायद होगा. anyway, MgCO3 wiki खुद भी आप लोग खोल सकते हो, but since we are on this journey together, I can go ahead and just show this to you. कहाँ गया इसका solubility? It's about 1 or 2 gram per. Oh, it's actually quite a lot, huh? No, that's density. I'm like, wait, what? That doesn't sound right. बहुत कम है solubility. Okay, wait a minute. Let me show you my screen. There you go. Solubility in water and hydrous. Look at that. It's point. It's quite low. Yeah, look at these numbers. Very, very low solubility. Let's say 25 degrees Celsius, right? So 0.0139 gram or 1 point or 13.9 milligram per 100 ml, right? This number is more than that. ठीक है? So it's not, इसलिए मैं I को 1 लेके चल रहा हूं. ठीक है? That's the idea. Okay. Second is simpler. अगर ये osmotic pressure निकलेगा, then it's very high, so it can't be done. Thanks, Shlok. Lovely, exactly. ये osmotic pressure may not be enough to do that. Okay, so this is how much I need to get out. And by the way, osmotic pressure की कुछ लोग बात कर रहे थे. Before we do all of that, let's convert this into, you know, a more sensible unit. This is gram per ml. I don't like that very much. What do I need to get it to? Let's get it into mole per liter. How do I get this from mole to liter? I basically have to divide with gram per liter, but I can do that only if I convert microgram to gram. So let us do, क्या करें? Either 10 power 6 microgram and 1 gram, right? Let's do that. Okay, ठीक है, ये करते हैं. और क्या करेंगे? और ml को लीटर में करना पड़ेगा, so we have to do 10 power 3 ml 1 liter. और बाकी क्या है? 84 gram per mole, right? That's it. उल्टा हो गया, सही हो गया? नहीं, सही है. Okay, 84 gram. So let's do all of that. So once we do all of these funny things, you get the concentration to be about 5 millimole. That's the concentration. Okay. You see where I'm going with this? You see where I'm going with this? Violets are red. It's for both. It is for both of them. Abhi, I'm talking about the advanced. The first 45 minutes of this session were for JEE Main. The last 15 minutes are for advanced. Okay, this is the advanced part of things. So are you good with what I've done so far? Yeah. I'm quite brave to use that browser. Yeah. Thanks. Funny guy. Any doubts on what I've done so far? I've got the concentration as this value right here. Okay. 5 millimole. Okay. So M into V is what I've done. Not concentration. I've got the amount. Mass balance करने के लिए. Right. As Shlok said, mass balance करने के लिए. Okay. ठीक है. So far so good. Okay. So now I've got 5 millimole है. ठीक है. Now how do I go ahead and say कि per ml, right? That's still there. That's all. ठीक है. How do I see कि 8 atmosphere कितना purify कर सकता है? Now for that I will use pi equal to ICRT. Again I will take I to be equal to 1. ठीक है? Again I'm going to take I to be equal to 1. I've explained to you why I'm taking I to be equal to 1. Because solubility is what कितना था? 0.0139 gram per 100 ml. बहुत कम solubility of MgCO3. That's why I'm taking this to be this. So once I do this, C, again take this to be 1 by 12 liter atmosphere, right? Liter atmosphere per mole, Kelvin इस यूनिट में ले लिया मैंने. 8 atmosphere दिया हुआ है, temperature 300. So this, okay, KSP value मैंने उसकी दी हुई है, ठीक है. So it can purify up to 0.32 mole per liter. तो तो ये तो बहुत कम है, 0.05 तो बहुत कम था. You got 90 percentile males, can you target advanced in quota 2-year classroom program? Karthik Singh, can I be very straight with you? You know the answer to this question. If you're, I mean, you know the answer to this question, Karthik. I feel you should give it your best for the second attempt of the JEE main exam, right? That would serve you much better than focusing on advanced right now. Because advanced के लिए दो चीजें जरूरी है. सबसे जरूरी है कॉन्फिडेंस, और श्योर नॉलेज ऑल्सो जरूरी है, कॉन्फिडेंस भी सबसे जरूरी है. द फैक्ट यू आस्किंग क्वेश्चन इज कि कॉन्फिडेंस आपको लग रहा है कि थोड़ा कम है, तो फोकस ऑन व्हाट यू फील यू कैन इंप्रूव ऑन, राइट, आराम से, बिकॉज इट इज इंपॉर्टेंट टू हैव रियलिस्टिक गोल सेटिंग्स. JEE main second attempt I think should be a focus. In the description we have a 1-week crash course, 18 to 22nd. If you want, you can check that out, that may help you. Okay, so I can, using this RO, purify up to 0.32 mole per liter. ठीक है. By the way, कोई सवाल सॉल्व कर रहा है? Shlok, Rek, anyone actually solving this question? So when I get to this concentration, the purifier will stop purifying. Okay, and तब पानी को बाहर फेंकना शुरू होता है. So I'm going to repeat that one more time. 8 atmosphere pressure is always being set, right? You remember that YouTube thing that I told you? YouTube manometer kind of a thing इसमें था. So I'll keep applying a pressure. So ये concentration, when it becomes 0.32 mole per liter, then it's like done. उसके बाद it will not work out. So then I have to throw this out. Okay. Throw water out at this point in time. This is when I have to throw the water out. Do you guys follow? Yeah? Okay. Trying. Okay. Cool. Rajesh Shinde, don't let anybody else tell you what you should and should not do. आप में खुद में कॉन्फिडेंस होना चाहिए कि हम क्या कर सकते हैं, क्या नहीं कर सकते हैं. Don't ask anybody else. It doesn't matter what the opinion is. I'm being very straight with you. जो करना है आपको खुद ही करना है. We are all here to support you in your dreams, right? But confidence has to be your own. So after this 0.32 वाला business हमने समझ गए. Okay. तो कितना पानी फेंकना पड़ेगा? That is the question. First question, how much water is to be thrown out? So 0.32 mole per liter into V is thrown out. Okay. और उसका पानी कितना था? उसका पानी तो you know, उसका पानी क्या था? उसका क्या था? उसका पानी नहीं, उसका क्या था? What is in the other side? This right here, right? This is millimole per liter, not per ml. वो हमने per liter उसको concentration निकाल लिया था. So this is the contaminated water, okay, where I am purifying 45 liter, and this is the volume I am throwing out. Okay, do you follow this equation जो मैंने अभी यहाँ बनाई है? Mass balance, as Shlok said in the starting, 0.32 times V, that's what I'm throwing out, will be equal to 5 mole per 5 into 10 power minus 3 mole per liter times 45 plus V, because I'm purifying 45 liters of that water. Yeah, थोड़ा गुम गया गलियों में कि गालियों में? गलियों में. All right, कॉन्सेप्ट चमक गया बट कम समझ में आ रहा है. Okay, Shlok, what do you think right now? Any doubts now? Let me know if you don't follow this. I'm here to explain this. Is this okay? Mass balance आप ही ने तो बोला था, right? Where did this come from? There are, again, look at that YouTube manometer thing that I told you, right? This was the initial thing. Then I keep applying some pressure. ये वॉल्यूम ऊपर जाता है, ये वॉल्यूम नीचे जाता है, तो टोटल वॉल्यूम तो सेम हो गया ना. That's what I'm saying. So this extra volume is basically 45 liters. This that I throw out is V, or in fact it is actually 45 liters plus V. ठीक है, यही हो रहा है. So 45 liters plus V into 5 millimole per liter is going to be equal to V into 0.32 mole per liter. ठीक है, cool. All right, अब आ रहा है. Okay, that's great. All right. Rushabh, more than study daily, the advice is you should want to do it. You, not your parent, not your teacher, you. It's all on you. No pressure there, guys. I'm saying कि आपको खुद मन करना चाहिए, और तो आप खुद पढ़ोगे, जितना कर सकते हो आप कोशिश करोगे. अब रिजल्ट किसी के हाथ में होता नहीं यार कभी भी. आई एम अ वेरी स्ट्रॉन्ग प्रोपोनेंट ऑफ दैट, राइट? इट्स इन द भगवद गीता एज वेल. यू फोकस ऑन योर प्रोसेस एंड नॉट रियली द रिजल्ट. सो बट इंटरेस्ट इज ऑन यू. So me saying होगा नहीं होगा doesn't matter. Okay, all right. So उसके बाद करो, you get the volume to be 0.7 liters. So that's it. That's the volume you're throwing out. Okay, if you solve this simple equation, you're throwing out 700 ml of water every day to purify 45 liters of water. 45 liters कोई दिन में पीता नहीं यार पानी. कितना पानी पीते हो? I think I drink about 4-5 liters, not 4-5. I think I drink about 4 liters of water. Maybe 5. Yeah, 8 glasses. No, it's 4 or 5. 4. I think I drink 4 liters. So maybe हम लोग साथ में collectively 8-7 and थोड़ा पानी खाने में भी ले लो. So you don't usually reach that limit daily. We don't. Yeah, we don't reach this limit. The other idea is कि चलो अगर MgCO3 dissociate कर गया, if you assume that it's not MgCO3, you have something else that's more soluble, dissociate हो गया, तब उसका concentration हो जाएगा 10 millimole instead of 5 millimole per liter. It will become 10 millimole per liter, and instead of 0.32, this will become 0.16 molar. सेम यू गेट अ सिमिलर इक्वेशन, फिर से उसको सॉल्व करो, बहुत ज्यादा पानी फेंकना पड़ेगा, उस केस में आपको 3 लीटर पानी फेंकना पड़ेगा. ठीक है, सोचना, इसको आराम से करना. आई हैव यूज्ड I equal to 2, ओके, फॉर दिस इन ऑल ऑफ द इक्वेशंस पहले. दिस फॉर यू टू डू थोड़ा सा होमवर्क व्हाटएवर. द सेकंड पार्ट, would this purify work with sea water? It will not work because my boundary is 0.32 molar. If it is greater than point, and again I equal to 1, when I is equal to 2 और भी कम हो जाती है boundary at 0.16 molar, and NaCl is 0.6, and that में तो it will become 1.2 because NaCl तो अच्छी तरह से उसमें पानी में डिसॉल्व होता है, डिसोसिएट होता है. ठीक है, तो इसका I is equal to 2, so the concentration is much higher than 0.32, तो वो नहीं कर पाएगा. So you need to know where your purifier fails. अगर आप purifier लेके डेजर्ट में जाओगे तो नहीं काम करेगा. उसके लिए you need a much higher pressure. That is the solution. इसीलिए डेजर्ट में जो वाटर प्योरिफिकेशन होता है रिवर्स ऑस्मोसिस से, बहुत हाई प्रेशर पे होता है, बहुत महंगा होता है. दूसरा, you should check that out, how water is there in most of the Middle Eastern regions. Very interesting stuff. खैर, that's all I had planned for you. I hope आपको मजा आया. Yeah. Normal human advantage. Are you trying to say I'm abnormal? Slow? I'm definitely abnormal. JEE के अलावा कौन सा अच्छा एग्जाम है? विराट कोहली. RVCE के लिए you can write Comet K. That's a good exam. Good मतलब that's a similar exam. Comet K है, VIT. There are too many exams actually. VIT, SRM, MIT, Manipal. That is right. All of these have the exams. I would suggest Comet K because Bangalore as a city is much better to live in as compared to all of these other cities. Just because it's a city. Otherwise, if you like the college life and all of that, there's Manipal, SRM, VIT, all of these colleges there as well. Interesting, they're all in the south. North में there's Harper University that I know of. Amity also is there. Yeah. Anyway, that's all I had planned for you today. If you want to sign up, JEE की तैयारी description है, description में links हैं. 18th to this is going to be there till 31st of May access, but the actual date is कहाँ गया? 18 से 22nd March. Apply these codes and you will get a couple of $100 off, $800 off or so from 4,000. Anyway, that was a plan. And that's what we had today. कल हम लोग करेंगे. कल, that's right. Tomorrow Friday we have a class. We have a class tomorrow on Friday and it's going to be GOC, General Organic Chemistry. उसी का नीट, आपके जो नीट का काउंटर पार्ट है, आज 6:30 बजे, 1 घंटे बाद मेरा सेशन है. If you want, please come check it out. It will definitely be beneficial to you if you are going to be giving the JEE main exam. And yeah, if your focus is JEE main and advanced, कल वाला तो definitely आना. ठीक है? Thank you so much for your time. हम लोग मिलेंगे 6:30 बजे. अगर आप आते हैं तब मिलेंगे, नहीं तो फिर कल मिलते हैं. कितने बजे? कल कितने बजे? कल भी 6:30 बजे ही है. ठीक है. See you. ऋषभ, what's your question? डिस्टिलेशन यूज क्यों नहीं करते? वो तो बहुत सस्ता पड़ेगा. डिस्टिलेशन से कैसे करोगे? हाँ, डिस्टिलेशन कैसे सस्ता पड़ेगा? डिस्टिलेशन में गर्म करना पड़ता है पानी, ब्रो. ओके, डिस्टिलेशन सस्ता नहीं पड़ेगा. डिस्टिलेशन में इज गुड फॉर छोटा छोटा चीजें. Anything where you have to provide heat is so much more crazy because you have to build a reactor. Oh, you asked a very interesting question. I'm going to take a minute on this. Okay. Distillation. Why not distillation? Think about this. Distillation में क्या क्या चाहिए होता है? गलती से मैंने chemical engineering की है, ठीक है? So I know one thing or two about this. You make all these fancy columns. And by the way, मैं जब college जा रहा था, when I was going to Surathkal, I saw somebody transferring one of these distillation things. Yeah, because Mangalore में there's a port and there's a lot of refining that happens over there. So like an 18-wheeler just taking one of these distillation columns along the way, right? These are crazy, like thousands of crores kharch hote hain to make a plant. Okay, so none of this is cheap. I have a friend who's a general manager at a fertilizer company. I know I'm going off track a little bit, but because he said it's cheap, it's not cheap. The exact cost between EIL, Engineering India Limited, and it was a joint venture. I forgot the second company. This is in Ramagundam. The cost of the plant was 6,000 crores. Okay, it's like only the second plant in the last 20 years that anybody's built in India. Fertilizer plant that makes ammonia out of that. It takes 2-3 years for things to start working. It's not cheap. I'm just saying that none of this is cheap. And either very big industrialists or the government, they're only two people who can make these plants. So the chemical industry is mad. All of these things, which are huge things. All right. Chemistry session में at least you can't rule. Shlok is saying something. We are done with the session. किसी को निकलना निकल जाओ. We're just doing time pass now. Chemistry session at least you can't rule out exceptions. Okay. All right, Shlok. GOC. Yeah. GOC में advance क्या कुछ advance होगा? Shlok. वैसे really Shlok pressure मत डालो bro. They have a lot of sunlight. Yes, Rushabh. Plane के wing के देखा था. Oh, Pawan Chakki, windmill. That's nice. All right. Aditya Vikram, you'll have to ask her. She's no longer a part of, here. She doesn't work anymore. All right. I think now we are going way beyond the scope of what we should be discussing here. Just because what Rushabh just said, I don't want to get banned. Yeah. Cancelled. Whatever. Did you see people who are commenting on Reddit? They got notices from their PR companies. If you guys are active on Reddit. Anyway, let's focus on JEE की तैयारी. बहुत publicity होगी इस चीज की, right? 18 to 23rd. Check it out. Use these codes if you like. Links in the description. I'll see you. Bye. Advanced का कुछ होगा for sure. We will do advances. Maybe we'll start with advanced PYQs. If you want these multi-concept questions, tell me. I'll try and get those as well from in organic. Bye. See you all. Tata. 6:30 बजे आज मिलते हैं. Next week कल.